Hi, everybody. I'm Quinn. I work at a company called Daily, where we make real-time infrastructure and developer tools for audio, video, and AI. And I work on an open source, vendor-neutral project called Pipecat. Pipecat has become the most widely used framework for building things like AI customer support voice agents. So today I'm going to talk about voice agents and coding agents and new LLM-powered games. Also a little bit about funny LLM failures. And maybe try to get an LLM to tell me a couple of jokes, as one does. But the high-level thing I want to talk about tonight is that voice agents and coding agents and new kinds of LLM-powered games are all basically the same thing under the covers. I think the thing we all figured out together as AI engineers in 2025 is that an agent is just an LLM in a loop. At the beginning of 2025, everybody said 2025 would be the year of agents, and it turned out 2025 was the year of agents. And what we figured out as we built all this experimental stuff was put the LLM in a loop, write some code that just runs the LLM in a loop, and then wire up tool calls and context engineering. Like, that's the architecture that works really well. So for the past few weeks, my canvas for experimenting in a totally open-ended way with this LLM in a loop idea has been building a game called Gradient Bang. Gradient Bang is inspired by one of the very first games I ever played on the internet, a game called Trade Wars 2002. A super simple game by 2026 standards. You fly around in a spaceship, you try to get rich and powerful through an incredibly simple trading mechanic. You help your friends, you fight enemies, and the magic of the game was that it was this open-ended social environment in a command line interface, which, you know, in the era of Claude Code and open code that James just showed is really relevant again, which makes me super, super happy. So the idea I couldn't get out of my head, and which I eventually fired up Claude Code to do something about, was what if that ship you're flying around in that Trade Wars terminal is an LLM? Like, it's the computer from Star Trek and innumerable other sci-fi stories. So let's play that game.
Hello, Jane here. Ready to start exploring the void. What can I check for you first?
Tell me how much of the universe I've explored.
You have visited 245 sectors, which is 5% of the universe.
Hey, that's pretty good in this big a universe. We should make some money, though. Let's fly to Sector 0, trade on the way, and recharge warp power when you get there.
That sounds like a great plan for profit and power. I will plot a course to Sector 0, look for trading opportunities along the way, and top off your warp capacitors at the megaport.
That sounds good. How are we doing so far?
The task is underway. We just started our first jump and are heading to Sector 720. Sector 0 is 46 hops away.
Man, that's a lot of hops. Are we gonna have enough warp power to get there?
We're doing well. We just sold your 30 neurosymbolics for 1470 credits in Sector 386. You are 44 hops from Sector 0 with 252 units of warp power remaining. Your ship has 300 total warp power. We have plenty to make the trip.
Well, that sounds good. Tell me a joke about space chickens.
Why did the space chicken cross the asteroid field? To get to the other cosmic ray, we are now jumping to Sector 2636, making good time to Sector 0.
So you'll note this side project has started to get a little out of hand. I have friends hacking on it with me. There's a whole UI. I wanted it to just be a TUI. It is a thing. But that's okay, both in general because side projects are awesome, and also specifically because this stuff we've been hacking on in the game turns out to be like way, way, way more relevant than I expected to building voice agents for enterprise use cases like customer support and user research and healthcare patient intake, which is what I do for my day job. I sat down and made a list of the 9 patterns we use in Gradient Bang, kind of agent patterns that are all useful beyond the source code of just this game. This is a 10-minute talk, so I'm only going to tell you 3 of them. You come find me later. The first thing you might have noticed from the game video is that the game LLM can do stuff while I'm talking to it. You saw the little task interface in the center bottom of the screen that just keeps doing stuff no matter what I'm talking to the LLM about. The basic idea is that for anything that might take more than 2 or 3 seconds, we spawn a long-running task, and we inject events from that task back into the voice loop context as semi-structured metadata. This long-running task pattern could be like a whole hour-long talk in and of itself. I have that talk. I gave that talk a month ago, but we'll just leave most of it as a bookmark to pull on later. I'll say one thing, though. I actually really wish Claude Code, which I love and spend like 10 hours a day in now, was designed this way. And I actually do think that most agents that have a human surface area in their UI will be designed this way in the future, with long-running tasks that just do stuff and an interaction loop that never blocks. Pattern 2, parallel inference loops that share some or all of their context. So an example of how we use this pattern is auto compaction of context asynchronously. If you do a lot of LLM in a loop stuff, you have to deal with the fact that LLMs get way less reliable as context gets longer. The subagent task actually helps. The subagent, like the long-running task pattern we just saw, actually helps with that, because you give the subagents fresh contexts. Only a subset of what those agents do goes back into the voice loop as data, but you still at some point have to do something about the fact that you're filling up your voice loop context. So this pattern is it's somewhat simplified from how it actually looks in the code, but it's 2 inference loops. One is the voice loop, the other is the compacting agent. Every time you trigger voice inference, both loops run. Almost all the time, the compacting agent is a no-op. There's a tool call that says, I don't need to do anything. But when, steerably based on the prompt, when you decide you need to compact the context, that inference call marks the end of the context now, and then asynchronously, it can take as long as you want it to, does the compaction. When the compaction is done, swaps back in that summarized context for everything that was before the marker. And this gives you effectively infinite context. You can talk to the agent as long as you want. You get a bunch of like decreasingly verbose summaries if you sort of do it simply, but you can also write a prompt that's kind of arbitrarily sophisticated to do the kind of compaction you want. Okay, third pattern. I'm just going to name check this one because I definitely am going to run out of time if I don't. Come find me later. Liquid user interfaces, dynamically generated by an LLM. Again, the implementation looks like 2 parallel inference loops that share a context. A big chunk of the UI you just saw is dynamically generated by the LLM, but not nearly as much as now I believe should be. I totally think in the future software is just going to be generated on the fly by LLMs at the UI level, but we don't know how to build that stuff yet, so it's fun to try. Okay, one last thing, specific use case for the long-running task pattern. This is a history agent I've been working on the last day or so. The idea is a long-running task that knows how to query and analyze events from the global game log. I think it's kind of working, but it's also definitely a work in progress, and it's a nice indication of how much you have to do to build really polished multi-agent systems. You've got prompt engineering and measuring and hill climbing on instruction following and reasoning, performance. How do you specifically share the context between multiple agents? What do you show, or in this case, say in the UI to make the multi-agent operations legible to and steerable by the human, and way more. And there are some funny failures here because it's not done.
Hello, Jane Eyre.
Hey, friendly ship assistant. Look up the tasks that we've started in the past hour and tell me what the instructions were for each task, most recent to least recent.
I don't have the capability to look up past tasks by time.
Oh yeah, that's a prompt issue. Your task agent can. Start a task agent to use the event query tool.
You are correct. I can use the start_task tool to query past events. Task 0001 has been started to retrieve your past tasks. I will let you know when the results are available. I found 6 tasks started in the last hour. The most recent task was a query of the event log, and the one before that was a summary of moves and trades to Sector 0.
What about tasks that were actually moves to Sector 0 as part of their instructions? What's the most recent one of those?
The most recent task that included moving to Sector 0 was fly to Sector 0, trading any profitable commodities en route, and recharge warp power upon arrival. Its ID is B92821 B-Day70 F4 Date 1 9099 1847 B7871F.
Tell me how many sectors we moved through during that task and how many trades we made. And while the task agent is thinking about it, you can tell me a joke about space scarecrows.
Task 0002 is running to count the moves and trades. Why did the space scarecrow win an award? Because he was outstanding in his field of asteroids.
I like how you added a of asteroids to the standard scarecrow joke you always tell me.
That task, Idaho B92821 B-Day70 F4 Date 1 9099 by 1847 B7871F, involved 20 successful moves to different sectors and 8 successful trades. It seems like a very active journey.
So I'll just close by thanking the Daytona team for inviting me tonight. The thing I've been working on in the last few days, in addition to that history agent, is writing a little bit of network transport glue code to be able to run these long-running tasks in Sandboxes, which is obvious for, I mean, it's generally useful for a bunch of obvious reasons, but also specifically, we want to launch Gradient Bank publicly so everyone can play. And as part of that, we want to make it possible to write your own agents and bring them in and run them in the world, which you need Sandboxes for. So if all this sounds like fun to you or interesting in a way that overlaps with the work you do or stuff you're hacking on, sign up for the waitlist or check out the source code or come hack with us on PipeCat, which is the framework all this stuff is built on. Thank you.